All right, you crazy kids. Here's your lecture on polyatomic ions and specifically Lewis structures. So, as a review, polyatomic ions are a group of covalently bonded atoms. That means they are sharing electron pairs, and they have both ionic and covalent characteristics. In the Lewis structure, all we're going to be doing is adding a bracket around our structure. We're going to include the charge on the outside of the bracket, and we're also going to include the charge when we calculate our number of valence electrons present. We have 3 examples for you today: ammonium, nitrate, and phosphate. These you should start to become very familiar with. I keep on saying you don't have to memorize them, but golly, it would be easier if you did. So ammonium in your packet is NH4 positive, nitrate is NO3 negative, and phosphate is PO4 3 negative. So our first one, ammonium, we have to figure out our total number of valence electrons. Nitrogen has 5, hydrogen has 4, but I also have a positive charge. So I should have 9, but because I have a positive 1 charge, I actually have 8 valence electrons. I'm going to decide on a central atom. The only one that it could be is nitrogen, because hydrogen never goes in the middle. So I'm going to have my nitrogen there. I'm going to surround it with my 4 hydrogens. I've used 8 valence electrons. I had 8. 2, 4, 6, 8. Each line represents 2 electrons. That looks like a really good Lewis structure. Now, to finish it off, what I have to do is put brackets around it to show everybody that it's a polyatomic ion, and I'm going to include the charge of the polyatomic ion on the outside. That is a complete Lewis structure. Let's do nitrate. So nitrate, we have 5, 6, 6, and 6 times 3, so that's a total of 24 electrons to work with. Now, nitrogen is going to go in the middle, and I'm going to start with my 3 oxygens on the outside, like this. So I've used 2, 4, 6 valence electrons. I have a bunch more to go. Let's see where they could go. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I've run out of valence electrons. I have a bunch of octets. Nitrogen has an octet, this oxygen has an octet, this oxygen has an octet. This guy on the outside, though, is the sad guy. No octet for him. So what I need to do is share additional pairs of electrons to make sure he has an octet. The electron pair that you share is important. If I share this pair over here and put a line there, now look at nitrogen. Nitrogen has 2, 4, 6, 8, 10 electrons. Too many electrons. So make sure you are sharing the correct pair. The correct pair to share would be the ones off of nitrogen. When I delete those and make them into a line between the oxygen and the nitrogen, I now have the correct number of octets around each individual atom, or a correct number of electrons, 8 electrons around each atom. I'm going to put brackets around the whole thing. Ba-boom, ba-boom. I'm going to indicate the charge on the outside, and that's a good Lewis structure. Phosphate. Let's count them all up. So we now have oxygen times 4, that's 24. Phosphorus has 5 plus another 8. That's a total of 32 valence electrons. Ooh, let's see what that looks like. Phosphorus in the middle. I'm going to start with my 4 bonds because I have to. I have 4 oxygens. That makes it look nice and symmetrical. And we're going to start adding valence electrons. I have used 2, 4, 6, 8. Let's keep on going. See if I can get to 24 and complete all my octets. So that's 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Oh, 31, 32. I was like, wait a minute. All right, so I've used my 32 valence electrons, and I have octets. The last thing I got to do is add brackets, put the charge on the outside, and we have our correct Lewis structure for our polyatomic ion phosphate. Hope you enjoyed it.